So this is a hard question, and we need to figure out these two or more numbers formed with two or more digits where the digits are in ascending order. So if we look at simpler examples here, it could be 37 or 267 or 3578. So there's many of these. And the way you want to think about this is if we just were to think about two-digit numbers, then one way you can think about it is if we just kind of list them out. So like this, 15, 16, 17, 18, then you move. So that's easy. You can even list them out, but still, it's work. And what you'll notice here, anytime you select a pair of two numbers, 1 and 5, you can form 1, 5 or 5, 1. There's only one that will be in ascending order. Same thing with 6 and 7. You can either form a two-digit number, 67 or 76. Only one of them would be in ascending order. So it's really to figure out the number of two-digit ones. You're just looking at how many sets of two numbers I can select from a set of 9 numbers. So this is really 9C2, or 9 times 8 over 2 times 1. And that's 36. And this is what you would get if you did it this way. Now the same applies for three-digit numbers. So let's say you select this pair, 378. We can create 6 three-digit numbers, 378, 387, 837, 873, 738, 783, and only one of them will be in ascending order. So to figure out how many of those three-digit numbers where they are in increasing order, it's really about finding how many sets of three numbers I can select from a pool of 9. So this is 9C3. Order doesn't matter. And you can compute this. 7, 8, 9, 3, 2, 1. And this would be 84. Now you can carry on this process because it would still apply. If you're doing 4 digits, it's the same idea. If it was, let's say, 2, 5, 7, 8, again, there's only one in that increasing order. So if you just count the number of sets, that would give you that many. So it is a hard question, but you have to kind of be able to see this link. And so the answer really is just 9C2 plus 9C3, 9C4. I mean, and you can compute these out as well. 9C7 plus 9C8 and then 9C9, which would be just 1. Now, you can also use the property that 9C4, 9C5 would be equal, because when you subtract that, you get the same number or add them. This would be equal to that, that would be equal to that. So you can use that to reduce a computation work, or you can recognize this property that 2 to the n, this binomial identity, I won't go over the basis of that here, is 9C0 plus 9C1 all the way to this. And this is the piece we need. N here is 9, 2 to the 9, which is, again, you may or may not remember this. 2 to the 6 is 64. 2 to the 7 is 128. 2 to the 8 is 256. That's 512. So that's 512. And all I have to do is to subtract these two. 9C0 is 1, and 9C1 is 9. So our answer is 512 minus 10, or 502. So just kind of comment about this question. I think because it requires you to have this new insight, it will be very difficult to do that in the exam, unless you have seen something before. I hadn't, which means under exam conditions, I'll probably just sidestep this question because it's very difficult to make that new connection when you only have a minute or 2 minutes per question. So if you've seen something very similar before, perhaps it's easier to make that connection. But if it's entirely new, at least it was for me, I wouldn't be able to do that. So in that case, I would be just skipping this question. But make sure you kind of understand the concept and you absolutely convince yourself that these are indeed how I explained makes sense to you, because it may appear in other questions in different forms. So it is a good practice in that sense. So to summarize, the answer is 502.